Our next question is a typical synthesis question, but we notice in this compound we have to build up a fair amount of complexity because our product has several new carbon-carbon bonds that don't exist in our starting material. And so in a case like this, I would want to think about what are some ways that we can form new carbon-carbon bonds. And so some reactions that immediately come to mind are the Grignard, as well as the Wittig reaction. And it turns out we can actually use both of those quite effectively in this case. So if we think about this final product, I'm just going to abbreviate the aromatic ring as pH because it won't be changed in any way during any of this synthesis. And specifically, if we had this alkene, which we could easily form from hydrogenation, it would form the product. We have an alkene that we could make from a Wittig reaction. And that Wittig reaction would be the reaction of this ketone plus this Wittig reagent. Then if you notice where we are in comparison to our starting material, our starting material could easily be oxidized to give us an aldehyde. And we can do that using PCC. And from here, we've probably seen syntheses like this before. We have an aldehyde, we need to add carbons to it. The easiest way to do that is using a Grignard. What Grignard should we use? Well, we need to add an isopropyl group, so it would be logical to add the isopropyl Grignard reagent. That gives us our alcohol back, but we've now added on the first group of carbons. And now you can see the only difference between where we are and where we're trying to get to is a simple oxidation step. Now there are other ways to do this synthesis, but this is going to be our most straightforward route to completing it. But the key here, and this is going to become the key more and more often in these synthesis problems as we move throughout this course, it's looking for the new carbon-carbon bonds, and how we form those carbon-carbon bonds is going to control how we do the rest of the synthesis.